Hello students. So today we will be discussing on a programming language which is a very popular programming language. This is Python programming language. Today we will be discussing on the very primitive concepts of Python. We will have a very basic introduction about object-oriented language, about procedural-oriented language, about the history of Python, and if time permits, then we will also see how to install a Python. So these are the topics we will be covering today. So there are language translators. Python uses compiler or interpreter, a big question. Procedural or object-oriented language. What is Python? History of Python. Merits and demerits of interpreted language. Understanding bytecode in Python. Why should we use Python and how to install Python at last. So now, starting with language translators. So what is a language translator? But before actually we move on to language translators, we must understand that what language does a computer understand. Obviously we know that a computer understands only machine language, right, which is obviously strictly in the binary form, that is 0 and 1. Machine language, obviously, since it is directly understood by the computer, so the computer will start directly executing it, and it will be obviously much faster than all the different kind of programming languages that we are interested in, right? But then the question arises that why we are not writing in machine languages directly? Because they are very hard to read, they are very hard to write, as well as if anyone has written a certain section of code, it is also very difficult to modify because the readability of such codes are very poor. So for these or such problems actually encouraged us to invent the high-level language. So the high-level language is basically a kind of language which is human understandable way, or which you can write in a language that a human can easily understand, right? So programs which are written in high-level language can be translated into the machine language for execution. Why? Because if I want my high-level language to be executed by the computer, then obviously there has to be someone who will be doing this particular conversion, right? So then comes a new term which is language translator. So the language translator is basically doing a very important job. It is basically converting a high-level language into its corresponding machine-level language for execution purpose. Now the language processors are also known as language translators. So we have got a new name for language translators which are known by language processors. And there are two types of language translators, or you can say language processors. One is compilers and another one is interpreters. I'm quite sure that many of you actually know what is a compiler, or what are different types of compilers, and what is an interpreter. And many of you may be also be knowing that what is the basic difference between compilers and interpreters, but still we will be covering all these topics in a very brief manner. So coming to the next slide, so we are interested in discussing the compilers first, right? So what is a compiler? A compiler basically checks the source code, and if that particular source code is error-free, it produces a complete program in a machine language which is known by object program, right? So this particular machine code is specific to a target machine. That means this particular machine code can be run by a certain operating system which has a specific kind of hardware. Only that particular machine is able to execute such a program. This machine code cannot be executable, or this machine code is not executable in all the different types of machines, right? So the machine code is specific to the target machines, since each machine can have different operating system and different hardware, right? So after compilation, the target machine will then directly run the machine code. So the machine code is basically meant to be created for a certain machine only. So obviously if there are any errors in the source code, the compiler always reports those errors at the very end, right? So if there are any errors, they are shown at the end together. Then the object code that is generated by the compiler, if it is completely error free, will be then linked together with other pre-compiled object codes, which are basically library files. Obviously when you write a code, you always include some kind of library files. You use some kind of procedures or functions from those library files. So all those library files that you are referring in your source code will then be linked up to your object code. Obviously the library files are pre-compiled, right? So after all these things are done, then only a executable file is created, which is loaded into memory for execution purpose, right? So now we will come to the next part, which is known by the term interpreters. So what is the interpreter? Again, interpreter is a kind of a language translator which basically translates one statement of the source code at a time, right? So it is an interpreted language. So in an interpreted language, the source code is not directly run by the target machine. So the next question may arise that what is a interpreted language? An interpreted language is a programming language which are generally interpreted without compiling a program into machine instructions. It is one where the instructions are not directly executed by the target machine, but instead read and executed by some other programs. So what I'm trying to mean is that the interpreter is basically not interested in generating a code which is directly targeted for a certain machine. It may actually generate a kind of code or an intermediate code which is understood by a certain kind of machine. That machine will then help that particular code to get translated to a machine code, right? So the interpreter reads a Python code or instruction, and if it contains some error, then it halts the translation and shows an error message. And until and unless the error message or the error is being corrected, the translator will not translate the next line, right? So if there is no error, then the interpreter translates it into its equivalent form in an intermediate language called bytecode. So this particular bytecode may be a new term for all of you. So what is this bytecode? The bytecode is a low-level platform independent representation of your source code. It is not the binary machine code and cannot be run by the target machine directly. So this was the kind of intermediate code that I was talking about, right? So this intermediate representation is basically not the machine code itself. If it is not the machine code itself, then obviously it is not targeted for any certain machine. So now this particular intermediate code, which is known by the term bytecode, will now be interpreted by some interpreter, which is then converted to a machine code for a certain machine. So that means when you actually use an interpreter to interpret a particular language like Python, then it basically transforms, or it basically generates an intermediate code which is bytecode, which is then supplied to a certain machine, which is then fed into a certain machine, which actually generates the machine code for the target machine, right? So obviously then it becomes a platform independent. This particular bytecode, a sort of intermediate code, is also generated in Java, right? Python is basically an interpreted language, but that doesn't mean that it only uses interpreter. It uses compiler as well as interpreter. So where does it uses compiler? When we actually execute a source code, it first compiles the source code into a bytecode, right? So this particular bytecode is then sent to a Python virtual machine. This Python virtual machine is basically an interpreter that actually runs the bytecode version, and it basically generates a machine code which is targeted for a certain machine. So here the bytecode is executed on PVM, and if an error occurs during this execution, then the execution is halted with an error message, right? So in Python, the bytecode is stored in .pyc file, right? And in Python 3, the bytecode files are stored in a folder named PyCache, right? So now comes what is a procedural oriented language, right? So procedural oriented language is basically a kind of step-by-step execution model. You have already studied a kind of procedural oriented language, which is a popular language, C language, right? So over there are basically different concepts of functions, procedures, or subroutines, right? So over there, obviously when you are calling a particular function, the data can be passed onto the procedures, and also it can be returned from a certain procedure, right? So obviously in many kind of, or in general in procedure oriented languages, there is a main procedure which determines the first entry to the program. From there the remaining branches actually move on. So from first you have to go into the main procedure, and from there you can actually propagate to many different kind of function calls that you have made from your main procedure. From main procedure, say you have called a function, say f1. From f1 you are calling maybe another function. If you have to start a program, then you have to start it from main function. You cannot start it from f1 or f2 function, right? So there are several other functions or procedures called on to perform certain tasks or specific logics through specific logic sequences, right? So there may be kind of it may be a conditional procedural call, right? So if a certain condition actually turns out to be true, then only a particular function is called, otherwise that particular function is not called, right? So it is all about calling a function, or it is all about breaking a very large task into modules, and the modules are basically performing their own tasks, and the modules can communicate with each other by passing the data which is responsible or which is required in order to execute that particular task that you are actually asking that procedure to perform, right? So what are the examples of procedural programming language? The examples are C language, it can be Pascal, it can be Fortran, etc. So now we will move to the next part, which is object-oriented languages. So in object-oriented languages, the main important priority is data. Obviously, we are going to break up the task into many different procedures and modules, as we have been doing in procedure-oriented languages. But in case of an object-oriented language, we will do the same thing, but our main priority will be on data. So procedures actually operate on abstract values called objects. So the procedures do not actually operate directly on the data item. It basically operates on objects, right? What are objects? You can consider object like, if I take an example, like computer science honors is having a specific kind of syllabus, right? And if you people are studying computer science syllabus which is created or which is formed by Calcutta University, right, then after graduating with computer science honors, you are an instance of the computer science syllabus which was formed by Calcutta University. Then you people are objects, and the Calcutta University computer science syllabus can be considered as a class, right? So the class is a kind of a blueprint. So object-oriented language basically deals with two important words, and one is class, another one is object. So class can be considered as a blueprint, right? So the computer science syllabus which is framed by Calcutta University can be considered as a class, which is a kind of a blueprint, and anyone who registers himself or herself in Calcutta University for computer science honors will actually study all the topics which are actually being framed by the Calcutta University. And after you graduate with computer science honors, you are an instance of this particular syllabus, so you become an object of this particular class, which is the computer science syllabus framed by Calcutta University. So over here, the data, what are the data? The data are the contents that you actually learn in the entire session of your computer science honors, right? So these are the data that is incorporated inside your brain, right? So obviously when you and your friend are trying to discuss about a particular topic, you may be passing some message among you, or you may be passing some messages among your friends in a group, right? So to discuss about a point. Over here also we are interested in doing so. So objects here interact each other by means of message passing. So over here here, what does that mean? That means if you know a certain concept about a particular topic, say, and you don't want to share it with any other friends in your group, then no one else can actually know whether you know that particular concept or not. So this is a kind of a hiding mechanism that you can do inside your object, right? So they cannot know what are you hiding, because it is there inside you, and you have the only authority to check whether that particular data is there or not, right? So anyone who is trying to modify that data has to go or has to request you to modify that data. Maybe you are maybe take another example, like you know a certain thing which is not totally correct, right? So you know a certain concept which you have read from a book, but you may have interpreted it in some wrong way, and a friend is helping you out with this particular thing. So it corrects the data that was previously existing in your brain, and it is incorporating, or it's feeding with some new data. So obviously the new data that is being fed to you will be accepted by you if you think that the terms that your friend is actually teaching to you is meaningful, is logical. So until and unless it is logical, or it seems to be logical to you, you are not actually substituting that new data which you are gaining from your friend, right? So this is what is a kind of message passing we are talking about, which is, I'm giving it a very real-time example. The set of functions through which they interact is called the interface. So here you can consider the interface to be the WhatsApp group, right? So you have your WhatsApp group, and there are many different friends who are in the WhatsApp group, and you people are exchanging messages among yourself. You may be discussing a certain topic, whether it may be related to your academic syllabus, or it may be any other topic, right? So whatever concept that you know previously and you are discussing on that topic, maybe you will come to a conclusion that yes, whatever you have known till now is the correct information, or there is some information that you have learned new from this particular discussion. So all the things that are being done using this message passing will be very much internal to your object, right? So the classes are basically a static definitions. Why static? Because they are blueprint, they are not going to change, and every year a new first semester students will be coming and taking up the course of computer science syllabus, but the computer science syllabus is not changing, right? So the class or the computer science syllabus, I'm comparing computer science syllabus to a class. So classes are a kind of static definitions which are not going to change, right? Only the instances are going to change. Some are going to score very high marks, some are not scoring that very good marks, some are actually failing to pass this particular course. So there may be different instances, but the blueprint is not going to change, right? So functions within an object are called member functions. So what are member functions in your example? Maybe you know a phone number of your friend. So if you want to or suppose you are having a phone number of your friend, and you are not able to understand a certain topic. So the way you can actually know that particular topic, or the way you can actually get your task done by your friend, is to call that friend using his or her phone number, right? So this phone number now becomes a member function to you. So this member function will actually give you an access to that particular object which you want to communicate, which you want to communicate over a certain topic, right? So all these things are basically a kind of message passing itself. So any message passing that you want to perform has to be done through member functions. So if I compare it again with your WhatsApp group, all the members which are included in the WhatsApp group are having their unique phone numbers. So you can consider those unique phone numbers to be the member functions of your objects, right? So using that particular member function, you are going to call another person, and that person is going to respond to your query if he knows that particular answer, or he or she is not going to respond if he or she does not know the answer, right? So what are the examples that can include in the object oriented language? Obviously Java, Python, C++. I cannot say it is a complete object oriented language, but obviously Java and Python are a complete object oriented language, right? So now what is Python, right? So Python, when you hear the word Python, what does the first thing that comes to your mind? You would say that it reminded you of a large snake, that probably may be coming in your dreams, or it may even eat you up, right? But it is not something like that. Then what is a Python? Python is basically an interpreted object-oriented language that is available on multiple platforms and in multiple operating systems. So Python is also an extensible language. What does that mean? That means you can add it with your own source code, modules, components that can be reused in other applications. So Python is also a kind of a language. It's a very, very dynamic language, and it is also an extensible language. What does that extensible means? That means we can add it with our own source code, modules and components, and that can be reused in other applications, right? So you can actually add your own source code in an existing module, and you can create a new software by reusing the already existing codes in that particular software. And you want to add something new, you can add your own code and incorporate that code, incorporate those files in that particular project, and a new kind of software can be made from that. So you have developed a student management system where you are tracking all the students that are enrolled in your college, and now you want to develop a library management system. Obviously, in library management system you want the students record as well, so you can actually put up the library management code files into the student management code files, and you are developing a new kind of software which is a library management system which incorporates both the library management source code as well as the student management code. So it is a kind of extensible language, right? So obviously Python interpreter is distributed under an approved open source license. That means that it is now and always shall be in future a free language. So obviously it is of open source, otherwise it cannot be an extensible language, right? So Python community is a very big community. So Python also gives you the capability to interface to database, to create CGI scripts that can be run from a web browser, to create applications that can run in a Windows environment, and to create extensible scripts that function in business or scientific worlds, right? Python is one of the foundations of LAMP application development. Obviously, if you people don't know what is LAMP, then LAMP stands for the 4 pillars of the open source community: Linux, Apache, MySQL. Apache is a server, right? MySQL and Python, sometimes PHP as well. It is also known as Linux, Apache, MySQL and PHP, but it is also known by Python as well. P is for Python as well, right? So now we should be coming to the history of Python. So basically, if you want to know the history of Python, you will be actually surprised that the Python is older than Java and C#. Python was first created in the late 1980s, right? In the late 1980s, it was developed by a programmer, Guido van Rossum, who is Netherlands based, and he was working at that time at CWI, the National Research Institute for Mathematics and Computer Science in Netherlands, and he was actually working on a language called ABC. The name of the language is ABC, on a platform called Amoeba operating system, right? So the ABC language was very dynamic language as well, because it didn't because while you want to actually declare a variable, you don't need to specify the data type that we actually use in C programming languages. The basis for Python language obviously was ABC. From ABC, something happened to Guido van Rossum that he actually went on to develop Python language. What is that? We will come to know that. And it was an excellent teaching language. Which one? ABC. ABC was an excellent teaching language, and it did not require any variable declaration and used identification for nesting of statements. Then what happened? Actually, this particular language lacks some feature of exception handling, right? So what did Van Rossum did? He took the best features of ABC and then built a new language around them, calling it Python, right? So Python was designed, and it was highly readable language, right? So you may be wondering that why didn't I tell something about Amoeba operating system? So the Amoeba operating system was an experimental microkernel based distributing operating system which was developed by Andrew S. Tannenbaum. I think you have heard the name Tannenbaum, right? And there were many others, but Tannenbaum was a prominent member, right? And Python actually came from the frustration of Van Rossum while he was actually testing ABC, while he was testing itself with ABC, right? While ABC was a kind of more of monolithic language, right, tended to produce large, hard to debug applications. The debugging or error debugging was not so easy in case of ABC language, and it was designed to be more of object oriented and modular, right? But the language was really lacking of well structured, and the exception handling or the error handling in that particular language was very, very poor. So what that Van Rossum did, he took the best features out of ABC language and went on to build a language which is known by the term Python, which is now a very, very popular language, right? So now what are the advantages and disadvantages of an interpreted language, right? So the first we'll discuss with the demerits. So the first demerit is you need to do more things to the end user. So obviously, since the interpreter loads and runs the individual source code files at runtime, you need to distribute all of the files that are needed by the interpreter. This means sending out potentially a large number of source files, right? The second demerit is the source files can be modified by the end user. The source file are obviously a kind of simple text files, especially in Python, right? This means that they are human readable, right? And thus human modifiable form also, right? So since the end user can read the files, it is not unreasonable to assume that the person can modify the files. This can lead to confusing problems, especially if the user happens to delete a file that is needed by the system. So the third point or the third demerit is errors aren't found until runtime. This is because an interpreted file is processed line by line. Any problems which exist in a given module will not be found until that module and the line containing that module are loaded and processed. This can lead to unexpected problems with end users and applications. The use of interpreted code therefore requires a high degree of path testing than the equivalent use of compiled code. What is a path testing? Path testing means all the different kind of conditional logic that is present in your program must be tested at least once. That means if there is a condition which, if resulted to true, will actually lead to follow certain instructions, need to be tested at least once. Every conditional logic statement should be tested at least once. So the path testing will be covered in a subject known as software engineering, which I think so you will be having in your next semester. So over there you can learn about the path testing, but for the time being I think it is clear that what is a path testing and what are the demerits of the interpreted language. Now coming to the advantages or the merits of this interpreted language, obviously it is easier to debug and maintain the code. So when you load a small section of code and try it out without having to worry about compiling and linking the entire application, the process is going to go a lot faster, which is usually a case in case of a compiler. We need to think about linking, we need to think about linking all the different kind of library files, and then only we can go and execute that particular program. Second advantage is easier to update the application code quickly. So obviously, since the edit, compile, link and to deploy process is now reduced to edit the file and replace the existing file with the updated version, right? So the process for updating an application is now streamlined. And more importantly, since there are no longer any issues about whether or not the program is running, or whether or not the executable file is in use, or whether or not the user has the right to change the file, everything becomes much easier to modify. That is what we have discussed in our previous slide. So the process for updating an application is now streamlined. So obviously it is going to be easier to update the application code quickly, right? So the next advantage is errors can be fixed quickly, right? So errors can be fixed quickly. And the fourth advantage is can be embedded in other languages, Python is an interpretive language, and the interpreter itself is rather small. The interpreter itself is a binary component, that can be included in other applications without including the entire graphical user interface system that supports the interpreter. So it is a big advantage, right? So this permits the third-party application to embed the binary component in their own application and to run scripts in Python from within their own GUI. So it's a big advantage. So you only need to have the interpreter itself, which is itself a very small file, and then you can incorporate into your own GUI and run it like a Python language, right? So it's a very, very big advantage, right? So now we'll move on to the next part, which is understanding bytecodes in Python. So how does a bytecode version work in Python? So the idea over here is to break down a code which indicates that what it is going to do and then a series of arguments to that code, right? So for example, if I take print value 1, say if I want to print a certain value and that value is value 1, right? Value 1 is that particular value, right? So the code for the print might be 01 in hexadecimal. The argument to the print statement is a value. So in the bytecode version of the source code, you might see something like this statement, right? So over here you see 01 value and end of statement. The end of statement is the end of marker, that where to end. Obviously you can understand that 01 is the code for print, but after that you are supplying some value, but how to know where that particular value ends? So end of statement is a kind of terminal marker where the interpreter will actually understand where to stop, right? So when the interpreter loads the bytecode version of the file, it reads the code and recognizes it as a print statement, right? Obviously from the hexadecimal code value. The interpreter then knows how to read in arguments until the end of statement marker is encountered. So in this way, a bytecode is actually understood in Python. So why should we use Python? So the first and the foremost reason is it is object oriented. So Python is an object oriented language, yes. So it is a structured language constructed around classes and reusable components called modules, which are member functions. You can call them as member functions, which allows you to easily move your Python code from project to project, saving you enormous amount of time, right? So the next reason why we should be using Python is cross-platform. So some languages, I'm not criticizing Java, but some languages like Java claim to be like write once, run anywhere as the tagline, right? So unfortunately, the reality is something very different from that, right? Most of the scripting language require major changes to run on different platforms because the core components are written in machine specific language. Python code is actually written in Python itself, so any platform that will run the interpreter will run them. So it is a great advantage as well, right? So the next reason is broad user base. So obviously it is because that many users are now trying Python, right? So when you are actually writing a particular language, it is always good to know that there are some others also who are writing the code in the same language, right? So it is a big advantage. Why? Because the Python community is a very, very large community, and if you are stuck somewhere, you can ask for help with those community members, right? So it's a big advantage. So Python is obviously well supported in third-party tools like MySQL, which is an open source database package, and Apache, which is an open source web server, right? So so that means we can easily develop some kind of Python scripting language as well, right? So we can write scripting codes using Python as well. So the next reason is good selection of tools available. So what is this? The Python, when you actually install Python, you can start writing the code with a command line compiler, or you have a IDE which is already supplied to you when you actually install the Python, right? It comes with a debugger and the help system as well. So obviously it will help you to write code. It will actually help you to debug a particular code. So the last reason is good selection of pre-built libraries. So Python actually comes with a large collection of developed code which you can reuse. So many of these classes are of general purpose functionality that you will probably need in your own applications, right? So now how to install Python. So obviously you need to Google Python, right, from your favorite browser. And after you Google Python, you will see the first link, which is python.org, right? So you have to go to that particular website and click on the download tab and download the latest version of Python. And then you should follow some simple steps of installation. It is as easy as the Python language, and then you are completely ready to learn Python, or you are completely ready to run any kind of code in Python, right? So what is the first step? The first step is that you have to Google Python and see over here. See over here, there is a welcome to python.org, right? So you have to click on welcome to python.org, and after you click on welcome this website, you will be directed to this particular website, right? So over here, see there is a downloads tab, and when you go and just move the mouse on the download tab, you will get another window, and this particular window is basically having such kind of a button like, which is having a caption of Python 3.8.5, which is a download for Windows, right? So you are going to click on this particular Python 3.8.5, and after that you have to select a particular destination where you want to actually download this file. And after you have downloaded, you are going to click on that setup file. After you click on that setup file, you will have something like this window, right? And over here, see there is a statement, add Python 3.8 to path. That means you are interested in adding Python 3.8 to your environment variables, right? So obviously do this particular thing so that you can run Python from anywhere. If you are running Python from command line, so you can easily run that particular Python from there also, right? Without actually moving to that particular directory where all the libraries of Pythons are there. You can run it independently from anywhere you want. So for that, you need to add the Python 3.8 to the environment variables. So you don't have to do it separately. This is already there in this option itself. So you need to check this option. Make sure that you check this option after you go for the next step. So over here you see there are two different options, install now and customize installation. In customize installation, you have the option of selecting what all the different features are you going to install in your system, and there is another option like where you want to actually install. In this particular install now, you have a path that is already specified, right? The Python will get installed in this particular path only. So if you don't want to make this path so complex and you want to make it very simple, then you can customize your own installation and set the path according to your own need, right? So it will depend whether you want to go with install now or you want to go with customized installation. It is completely your own choice. So after you actually go with one of the options, the next steps are very easy steps. You just need to click on next, and then the particular installation of Python will be done successfully in your computer. And after that particular thing is done, you now have to see where the Python is installed or whether the Python is actually installed or not. So for that, I'm using Windows 10, so we'll go to the start button menu over here, and over here if I go to Python or search for P, all the application software which starts with P, if I go to P, then over here see this is Python 3.7. Since I have already installed Python of version 3.7, so it is displaying over here as 3.7, but when you people will be installing Python, you will be getting as 3.8.5, which is today's current. Now it is the latest edition or latest version. So if you see the Python 3.7, or when you install, you will get it as Python 3.8.5. You will see series different software applications which are installed, right? So over here see there is a caption like idle, right? This idle is basically a IDE environment where you can actually run your Python commands, right? So you can click over idle 32-bit or you can click over 64-bit. If your computer is 64-bit, then you can click on 64-bit, and when you click on 64-bit idle, you will get something, a kind of interactive shell. This is a kind of shell, right, which is in front of you. And if you just see the prompt over here is like this, right? It is a kind of a greater than symbol, right? So after that, you need to type your own command or Python command. So over here I've just written print hello Python. You have to do it in brackets and double quotes, whatever text we want to write. So hello Python. After writing hello Python, if I just enter, if I just click on the enter button, then I will see that the hello Python is written over here, right? Whatever we are supplying the argument to the print command, that will be printed in our console or in this particular interactive shell. So this is the way we actually do some commands. So this is a very interactive shell. This is a Python ID which comes pre-installed in your Python version, and you don't need to have any other ID, right? If you are interested in installing any other ID, you can, but this idle ID is enough for everything that you want to actually run on this Python interpreter shell, interactive shell. So if you actually want to check whether Python is actually installed from a command prompt, so you can do it by going to the command prompt window, and from there, see, I have written Python, then dash version. So it's Python 3.7.3. it's showing up over here. So if you are installing the latest version of Python, that version will be displayed over here. So now we will move on to how to use Python in Linux. Generally, when you install Linux, Python comes in pre-installed manner, right? So in order to check whether Python is installed or not, we will first type Python dash version. So when you type this command, if you see something like this, then the command Python not found, then you might have installed Python 3, right? You have installed Python 3 version. Python 3 version is a more advanced version. So in order to know the version, you then have to write Python 3 dash version. So I have written over here Python 3 dash version, and for this I'm getting Python 3.6.7. Again, I've already told that I have not installed the latest Python version. My system was already installed with a previous version of Python, and I'm just continuing with that. So I'm getting a version at 3.6.7. Otherwise, you people will get as 3.8.5. So now, how to run a program in Python? So if I just want to write a Python program, or I want to run a Python program in Linux environment, then the first thing is that you have to write a code somewhere in a file, right? So for this, I'm using cat command, and I'm just creating an instant file, a live editor, you can say, using cat command and this redirection arrow, and the name of the file is test, and the extension is .py, right? So the extension of a Python file or Python source code is .py. So after we actually type this command and we press enter, we are now with a live editor, and we can type whatever we want. So over here we are going to type print hello world. So this particular editor is not a IDE like editor, right? So it's a simple kind of text editor. You just have to remember the formula. You just have to remember the syntactical structure. Otherwise, it is difficult for you to know whether you're writing the correct syntactical format or not, right? So this is print hello world. So when you just write it and press Ctrl D, you are now out of the live editor, and the prompt again comes out over here, right? So now in order to run the particular file, you have to type Python 3 test.py. Python 3 is the version of the Python that is installed in your or the generation of the Python that is installed in your system, and test.py is the file name. And when you just type this particular command, you see that whatever argument that we have passed inside the print command, that particular argument is now displayed in our console, which is hello world. So in this way, you are going to run any Python program in a Linux environment, right? So now, in order to run a Python code in a file in Windows system, right? Previously we saw that we have actually run a particular Python command in an idle environment, idle IDE environment. Now what we want is that we want to run a Python code written in a certain file, and that file I need to run in a Python idle environment. So how to do that? So again, you first have to open the idle environment the way I've showed you in the previous slides. First you have to open the idle IDE environment. After that, you have to go to file From file, you see there is an option new file. You can also fetch this option using the shortcut button of Ctrl+N. So after you do this, you will see a new file window is opened over here, right? So it is not saved, it's an unsaved file window over here, opened over here. Again, this particular editor is a kind of ID like environment. See, when you are writing print, this is changing its color, so it is able to determine the commands of Python, and the text which I have written, or the string that I have supplied within the double quotes over here, this has also changed its color. So it is a kind of ID which is also available in the file also, right? So it's a great advantage for us, right? It looks good, and it's also helpful in writing large programs in a particular file. So after you write your code, whatever code you want to write in this particular file, then you need to first save this file. So for saving, you have to go to file again and see there's an option save as. You can also go with save, or you can go with save as. So since I'm saving it for the first time, this file, so I will be using save as, and use after save as. After you click on save as, you can save this file wherever you want, because now the path, now the Python is set into the environment variables. While installing Python, we have set the Python into, or we have registered Python into environment variables. So it will not matter where we are going to store the Python file. Wherever we store, the Python is going to fetch that particular file and run our file. So I have saved that in my desktop. So after I have saved that in my desktop, so how to run that particular file? So for that, you need to go run, right? So you need to go to run, and then there's an option called run module, which can also be fetched using the shortcut button F5. If you press F5, or you go to run and then run module and click on the run module, you will see that this particular output is displayed into the interactive shell, idle interactive shell. So see, the output is displayed in the idle interactive shell, which says hello Python. So in this way, you can actually run a particular code which is written in a certain file in a Windows environment. So now, how to configure Python? Configuring a Python means, since the font size which you see over here is maybe inappropriate for some people or some of you, so obviously you might want to change the font type or font size, anything you want. So you go to options, and there you see there's an option named configure idle. So you go to that configure idle option, and then from there you will see a window opening, which is the window says its settings, and from there you see there are several different options. We will come to each of the options later, but for the time being we are interested only the font tab. So it is by default selected with Courier New or Courier New font type, and the size of the font and the size of this particular font type is by default set to 10. So you can increase, you just click on this particular button and you will see a set of values. You can increase or decrease the size of the font, and also you can set it to bold, so it will be much more sharper to look. It's also good to look. So it is up to you that what you want. So according to that, whatever changes you make sure that you applied that changes, okay, and come out. After you come out, all the changes that you have made will be reflected into the idle interactive IDE environment, right? So in the next class we will be discussing in depth about Python, and in the next class we will be writing our first Python program as well, right? So this comes to the end of today's lecture. Thank you all, and I hope that you have understood the basic introduction about Python. It's not even a basic introduction, it is about the history, the basic object-oriented system, the in-depth analysis of what is a interpreter, what is a compiler, or how does an interpreter actually works, right? How does a bytecode in a Python actually works? Why should we actually use Python? It's all about the very basic introduction that you need to know about a certain language before you actually start learning that language. So thank you all.